This is Algebra 2 with Trig 4.7, Day 1. We're going to look at a concept called completing the square. It's another way to solve equations, solve quadratic equations. We want to recall from the very beginning that there was a perfect square trinomial, and it had this pattern that if you could take the square root of the first term and square root of the last term, and if the middle was 2 times that product, then you knew it could be represented as a perfect square. Perfect square meaning parentheses squared. We look here, n squared and 36 are both perfect squares. The middle term, our b term, is 2 times those two products. So we know that in this case we're going to get n minus 6 squared. This is using this special rule. We didn't make tables, we didn't use the box, we didn't do factor by grouping. You could, you'd get the same result every time. Let's take a look here. Can you square the first term? Can you square the last term? Is the middle 2 times that product? 4h? It certainly is. So this is h plus 2 squared. Remember, you can't distribute your square here. It's not h squared plus 4. You have to write the parentheses out twice and FOIL it. Then you would get h squared plus 4h plus 4. A little bit more complicated looking. Can we take the square root of 9x squared? Sure, we get 3x. Can you take the square root of 4? Of course. Is the middle term 2 times that product? (6x times 2 is 12x. So yes, the middle term is twice that. So we're going to say 3x. We're going to say minus 2, because your b value is negative, 2 squared. You'd have to write it out with 2 sets of parentheses for you to be able to check that with FOIL. But it would be 3x times 3x. 3x times negative 2 and negative 2 times 3x. That would give you negative 12. And negative 2 times negative 2 to give you positive 4. If you have a perfect square trinomial on one side, you can rewrite that side as a factored form. So here we have x squared plus 6x plus 9. This becomes, when we factor it, a perfect square. You can take the square root of your x squared. You can take the square root of your 9. The middle is 2 times that product. So yes, it follows the pattern that we've talked before. Now, what can you do with an equation in this format? There's no b term. You cannot take the square root of standard form, but because we have parentheses squared, we're taking the square root of something being squared. Take the square root of both sides. So we're going to get x plus 3 equals plus or minus 6. So we have x plus 3 equals 6, and x plus 3 equals negative 6. So now we came up with 2 values. Those are going to be called your x-intercepts. You could call those the zeros of your function. You could call those the roots of your function. What if you don't have a perfect square trinomial? What can you do? Can you create one? So let's just look at x squared minus 26x plus what? What would the c value need to be if we wished this was a perfect square trinomial? Remember, when we test this out, we always talk about, is the b term twice the product of your a and your c? Is it twice as big? So what we want to do is take your b value and cut that in half. That's your b divided by 2. Then we're going to square it, because we usually talk about square rooting it, but we're going to square it to get it bigger. So here we get negative 13, which is 169. So if that c value was 169, then x squared minus 26x plus 169 could be written as x minus 13 squared. If you FOIL that out, remember, square means write it twice. X times x is x squared, negative 13x, negative 13x again, and a positive 169. So you see, x minus 13 squared is the same thing as x squared minus 26x plus 169. So, the process of completing the square, it allows us to solve a quadratic. We're looking for the value of x. We're going to take the b value divided by 2 and square it. We need to be sure that the leading coefficient is a 1, and you might have to do some things if it's not. We're going to move our constant to the other side of the equal sign so we can get our x squared plus bx all by itself. We're going to take half of the b value and square it. So we come over here. Now, some of you might recognize, could I add the 19 over and do it the old-fashioned way, factor it, what multiplies to be 19 and adds to be 20? You can figure that out. But just to start with a nice easy one, I like to leave a gap, because we're looking for what this c value would be. We take our b value divided by 2. We get the number of 100. So we're going to add the 100 to the left side. We're going to add the 100 to the right side. So that gives us a perfect square trinomial. X times x is going to make x squared. X times 10 and 10 times x would give us the 20. And 10 times 10 is 100. Remember, whatever you're squaring after b divided by 2 will always go into this spot. Now, if we were writing this in vertex form, we could subtract the 81, but because we're solving, we're going to take the square root and get x plus 10 equals plus or minus 9, and then we need to write this out in two equations. X plus 10 equals 9, and x plus 10 equals negative 9. When you subtract the 10, x equals negative 1. When you subtract the 10, x equals negative 19. So we get two answers for what x could be to solve this equation. Notice we did not use our normal factoring. We did a process called completing the square. for this one, even if we wanted to try factoring, nothing multiplies to be 1 and adds to be -10. So let's consider completing the square. So we're going to move the 1 across, take our b value divided by 2, square it, so that gives us the number -5, or gives us the number 25. So we're going to add the 25 to both sides of our equal sign. Why did we add the 25 to this side? Because that now makes this a perfect square trinomial. Be sure you understand why this is x minus 5 squared. What does it mean? How can you verify that? You need to write it out twice and FOIL it together to show that it makes that. But these are equivalent. Now if we're solving for x, we would take the square root of both sides. So we have plus or minus the square root. You've got to include your plus or minus. We're going to add 5 to the other side. Then you have plus or minus. When you take the square root of 24, that is 4 times 6. That makes 24. You know the square root of 4, so we're going to call that 2 square root 6. You can either write it out twice as 5 plus 2 root 6, 5 minus 2 root 6, or you can just give your final answer in this form, because you can't group those two together. Last example. Do you notice what's different about this one? When we subtract the 100 across, we get negative 150. This has an a value, so we have to factor the a value out. If we're solving, then we can divide by the 3. When you divide that by 3, we get negative 50. We're going to take our b value, divide it by 2, square it. We're going to add the 36 to both sides of the equal sign. So we get x minus 6 squared equals 14, negative 14. So when you take the square root of both sides, we get x minus 6 equals plus or minus the square root of negative 14. Well, we don't like to take the square root of a negative, remember? So that's when we use our I root 14. And then add your 6 to the other side. So x, add the 6, plus or minus, look at the order. The 6 would go in front of the plus or minus. I square root 14. That just implies that this parabola does not cross the x-axis. So we have an imaginary solution for where it does, but at least we can answer the question.